Welcome to the next lecture of wireless research. So we assume that we will be using machine learning and deep learning in research in wireless communication systems. So it becomes very important that we introduce a little bit of machine learning and deep learning and artificial neural networks, that the concepts that we will use in upcoming lectures. So what is machine learning? The machine learns to take a decision. So how does it differ from conventional computing systems? In conventional computing systems, we used to have X, the input, and we provide it to a computer, or say a calculator, and we give it a function, say a squaring of the input. Then based on this function, whatever this function is mathematically, the computer used to evaluate the output. It was y is equal to x square, suppose. So based on the input and the given function, the corresponding output was generated. In machine learning systems, what happens is that we provide the input and we treat the system as a black box, and we also have the output. Now we ask the machine, that is the computing device, that what was the function that mapped x into y. When it understands the underlying function, it becomes a machine learning system. So basically in traditional programming languages, we used to have data and we used to have the program, which was nothing else but f of x. We'll feed that to the computer and the computer will give its output. But in machine learning, the data and the output are fed, and the underlying function that maps the input to the output is undetermined. For our conventional purposes, the input data we will set to be the features and the output will be labels. Similarly, in machine learning, what happens that we provide both features and labels, and it understands what was the underlying program. Based on whether the input data is available, input and output x and y are available or not, it can be supervised, unsupervised, semi-supervised, and there is also an optimization algorithm where we use agents to optimize the system, that is called reinforcement learning. So based on whether the features and labels are available, if both are available, then it is called supervised. If only one is available and we use for classification, it is unsupervised. There is also a category called semi-supervised, and these are machine learning models. In a broader sense, it can be unsupervised and supervised. The supervised can be used for classification and regression. This is the most important thing, because in wireless communication systems, we will have problems that will either we will classify like modulation schemes, that x1 and x2 are two symbols, whether this is BPSK or this is FSK, we don't know. So we will have number of classification problems that can be solved, or we will have a regression problem. Regression problem is when we give x comma y, we give some new x and we identify what is the new y. So this is a regression problem. There are various types of models that we will use generally for regression and classification purposes, starting from linear regression, logistic regression, decision tree, random forest. So these three are for classification purposes, and if we use them, support vector machines, nearest gain, nearest naive Bayes. So all these are basically machine learning models. Machine learning also has a different branch, and that is most important to us, and that is said to be deep learning, which is based on artificial neural network, and then we make a more complex architecture to get a deep neural network, which can be again for other purposes converted into conventional neural network and recurrent neural networks. Recurrent neural networks, RNNs, have other types like LSTMs, bi-LSTMs, and they have also been now converted into transformers, which are agents. And so this is the whole levels of architecture that machine learning algorithms are there, and all of them can be used for improving our wireless communication systems. So how it started? It started that two scientists, this McCullough and Pitts, modeled the human nervous system, because that is the most complex. Human brain is the human nervous system is the most complex computing device. So the nervous system was assumed to be consisting of a net of neurons. They will have their ends, the starting and end point were called soma and axons, and soma and axons were said to be connected through synapses, And what happens is that whenever there is an impulse initiation, whenever we think that we want to do something, that excites, and that if that excitation crosses some given threshold, then it gets activated, and that activation comes in forms of actuation. There are about 10 billion neurons, 30 trillion interconnections, and is the most complex parallel computing device ever. Based on this, the neural network concept was given that if that impulse, and how many impulses are there, so if the impulses are from x1 to xm, and we actually model them using some product, these product are wk1, wk2 till wkm. For the kth neuron we are writing, and we'll add some constant and a DC bias to it, and then we will have this vk, and we'll supply the vk to that threshold device. So that threshold is activation function, and output of the activation function is yk. So basically the Markov-Pitts model is a mathematical representation of the human nervous system based on the neurons. Here we will have the features, the x, the labels, y's, in between we will have weights, the w's are called weights, and biases. How will we define the equation for vk? Vk is nothing but summation of all the weights multiplied by all the inputs that are available plus the bias. And what happens to the yk? Yk is nothing but the output of this activation function. So we provide yk as phi of vk. So it happens like if we touch something hot, we suddenly remove our hands. So that if we touch, the nervous system considers an activation that okay, this temperature is too high and we should just remove. So there is an initiation, and this model, this activation and before that weighing with addition of bias is the Markov-Pitts model based on which the artificial neural networks have been defined. So artificial neural network, these are artificial neural networks, which means the human nervous system is original and these are artificial. So they will have different layers having different number of neurons. This is very important. In our optimization problem, we will have to optimize how many numbers are required in each layer and how many layers are required. Then we will have neurons which will have their own activation functions. I will detail which are the activation functions that we generally use. The output of one neuron is connected to the input of the other neuron. If we go from left to right, the signal flow is the forward direction. This is called feed forward network. We will have an input layer, we will have an output layer, and in between how many layers are there? All those layers are said to be hidden layers. The model is trained based on input and output relationships. The process can be either classification or it can be regression in the basic. Otherwise, we can also go for recurrent reinforcement learning. So this model, when presented, is said to be the multi-layer perceptron, MLP. So MLP has set of inputs. These are provided to the number of neurons. So how many number of neurons are here? You can understand that the number of neurons in this will be n, because there are 1 to m inputs. These will be the input layer. Then we will have hidden layers. I am just showing here one hidden layer, and these hidden layers will be connected to the input layer. Not necessarily the number of neurons in the hidden layer will be equal to the number of inputs. They can be more or they can be less, but they will be connected. This will be a hidden layer. This is suppose the first hidden layer H1. We can have several other H1, H2, so on and so forth, depending on the problem and its optimization. But all the neurons can be connected to the previous branch, which means the hidden layer H1, all the neurons will be connected to the previous layer, and then it is said to be fully connected. And then this is said to be fully connected. Fully connected. We can also use a function called dropout to eliminate some of these connections, but if not mentioned, the general thing that is there in the coding domain, the function assumes that all the neurons are connected to all the neurons in the previous layer. Then similarly we will have the output layer. Suppose there are n outputs, so number of output neurons will be equal to number of output that are there in the system, and they will be connected to the previous hidden layer. If it is just demonstration for H1, there can be number of hidden layers, there can be number of neurons per hidden layers. So that is where the architecture increases in complexity. Basically, this is the output layer. So number of neurons will be m in the input, number of neurons will be n in the output, and deep learning is a subset of machine learning in which this artificial neural network that we used will have a number of hidden layers. So if we are using, in principle, if we are using H1 and H2, two hidden layers, it becomes deep neural networks, DNN, deep learning models. So deep learning model is nothing else but not possible for ANN to predict or classify based on X and Y with one hidden layer. So if one hidden layer is not possible to solve our problem, then we'll use multiple hidden layers. When we increase the we can use more number of hidden layers. It means the time and the complexity of the architecture increases, and this therefore means that our network becomes deep neural network. So ANN is a subset of DNN, and DNN, as we illustrated, is a subset of machine learning. What is the difference between deep learning and machine learning? As I always said we started with this discussion with machine learning. So the computer understands to solve the problem and what is the underlying function. That can be done using anything, but if we use the artificial neural networks, that is the model of the Markov bits that represented the human nervous systems in terms of X, W plus B and an activation function, and we use multiple hidden layers, then it becomes deep neural network. So basically deep neural network is a subset of machine learning algorithms. If we have a small data, we can use machine learning, but as I said, when there is large data, the nervous system is the most complex parallel computing device that is there, and therefore its artificial representation in A and further DNN can be used for large amount of data. So automatically the DL, it's very important, the DL automatically finds out the features which are important for classification, and same also happens for regression. There's also a term called artificial intelligence. So everything that comes under the umbrella of like machine learning, deep neural networks, artificial neural networks, all are subset of AI. So AI is basically when you have a decision making. This is the most important point. Other points are there, but this is the most important, that when there is a computing device that has a decision making capability as humans have, they becomes artificial. But how do we do that? That is done using machine learning algorithms, using artificial neural networks, using multiple hidden layers to form deep neural networks. So it is not AI is the main thing, and its subsets are machine learning and deep learning algorithms. So as here it is mentioned that deep learning and machine learning are the subsets of artificial intelligence. The applications which are generally there are like self-driving cars, news aggregation and fraud news detection, natural language processing, virtual assistant, entertainment, visual recognition, fraud detection, healthcare personalization, adding sounds to silent movies, everything and anything that can happen by itself. You go to a page, you search for a cricket ball, you go to YouTube, you see ads of cricket balls. So anything that happens by itself, you didn't search for it, you just search it once, but there are machine learning algorithms that are identifying what your interest is, and they are showing advertisement based on that. It's just a basic example. If you go to any robot system, you will see that the robot in itself is able to write codes, or it can also be used in hardware implementation. So in IC fabrication, the robot is taking the IC from one burner to another burner, and then it is making the whole ICs by itself. So there in the automation, wherever there is automation, there is something which is doing the things by itself. It has understood the process. That's where you can use this artificial intelligence. But for this course, we are interested more towards how can we apply this in wireless communication systems. Autoencoders have been established as communication systems. We'll see how autoencoders can encode and decode, and as an end-to-end communication system, train the network to understand the underlying channel models. Channel state information acquisition for massive MIMO systems is a very open formula. Coverage enhancement for cell edge mobile users is also been done using artificial intelligence or deep learning models. For unmanned aerial vehicles, where will be they placed to achieve the best throughput, to use the minimum power, to give less latency, so that placement can be done automatically based on deep neural networks. If there are interferences in the system, they can be neglected. capacity optimization, energy efficiency optimization, adaptive modulation and coding. So here also everything will be automated. So there will be a model that will understand the features and the labels. Remember, the features are input and the labels are output, and on that basis it will just click. In a large domain, you will see that applications in wireless communication systems, starting from resource allocation, interference management, power management, network traffic control, automatic routing, hardware mitigation, CSI classification, error detection, and MIMO, beamforming, autoencoders, modulation classification, multi-user pointing error. So we will see some of them in the subsequent lectures. So we'll just establish one more lecture for deep neural networks where I will discuss about activation functions, and then we'll start with actual problems. So we'll see some simple problems, but for wireless communication systems, and we'll apply deep neural networks to solve those problems. So hope this lecture helps you to just a glance at what new deep neural network will be used in wireless communication systems, and in subsequent lectures we will apply them. Thank you so much.